Okay, section 1.4, perimeter and area in the coordinate plane. Our objective for this lesson is to first classify polygons, which means we're going to have to know what a polygon is, find perimeters and areas of polygons in the coordinate plane. So first we need to talk about what a polygon is. Okay, first off, a polygon lies in a plane. So it's a figure that's in a plane, but it also has to be closed. So we'll just call it, say, closed plane figure. We'll go ahead and we'll kind of talk about these words here as we go. First of all, closed means once you're inside, you can't get outside, and if you're outside, you can't get inside. Okay? Meaning there can't be any holes in it to where you could walk out of it. Plane means the whole entire thing lies in one plane. This lies in one and only one plane. Lies in one plane. So it's closed. A closed plane figure, okay? Another thing, it's made up of segments. If you remember what a segment was, segment, okay, has two endpoints. It's made up of segments, okay? And those segments we refer to as sides in a polygon. So we call those segments sides. So it's made up of segments that intersect exactly two sides at their endpoints. So it's made up of segments that intersect exactly two other sides at their endpoints. And those endpoints we call a vertex. Plural for that is vertices. Spelled that way, vertices, that is plural. Okay, so it's basically the shapes we've gotten used to dealing with. For example, triangles. A triangle is a polygon. Okay, so examples of some things that are polygons over here. Triangle. Polygon, because it's made up of segments. One segment, two segment, three segments that intersect. This segment only intersects two other segments, the one on each side, and they intersect at their endpoints. Okay, so that's a polygon. Another polygon. Here, this trapezoid. And we'll talk more about trapezoids later. Trapezoid's a polygon. This one's made out of four segments, 1, 2, 3, 4, but again, they only intersect at their endpoints. Okay, and they only intersect, this segment only intersects these two. This one only intersects these two, so on and so forth. So it's also important to know what's not a polygon. So let's go ahead and let's, over here in the very, very corner, let's look at not a polygon. For example, circle, not a polygon, not made out of segments. Okay, something that goes like this, not a polygon. First of all, it's open on this end, and these two segments intersect each other in the middle, in the inside, not just their endpoints. Also, the figure can't be open. So something like that, not a polygon, because it has that open bit. Again, it has to be closed. Okay. Any type of curvy, even if it has a couple line segments in it, not a polygon, because it has to be able to be drawn. I always like to think it has to be able to be drawn with a ruler. I can draw all the sides nice and straight with a ruler. Okay, so all of them are called polygons. Okay, but just like you're called a human or a sophomore or a freshman, you also have a name that's associated just to you. Okay, so polygons actually have a name associated to them depending on the number of sides they have. Some of these you already know. Okay, so we're just going to go ahead and fill this in the number of sides. A three-sided figure is called a, if you know, write it in. Triangle. Three-sided. Four-sided one, this one you may not have heard before. Hopefully you have. Nope, not a square or a rectangle. Those are types of four-sided figures, but any type of four-sided figure is called a quadrilateral. And really, this is just broke down into its pieces. Quad meaning four and lateral means sides. So quite honestly, it breaks down into four sides. Okay, five-sided figure is called a pentagon. we have a special building found in Washington, D.C. with 5 sides. We call it the Pentagon. Okay. The six-sided figure is called a hexagon. What helps me remember hexagon is the number 6 is written S-I-X with an X in it, and guess what? Hexagon also has an X. The number 6 is the only number with an X in it, so hexagon with an X. Okay. 7-sided figure is called a heptagon. I really don't have any shortcut way of remembering that one. It's a heptagon. 8-sided figure is called an octagon. Octa, meaning 8, as like an octopus, has 8 legs. An octagon has 8 sides. Do you notice we have gone, 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 gone at the end? Gone. Okay. Poly means many. Okay. So poly means many. So then if we now break it down to octa's 8 sides and so forth and so on. Okay, 9 is nonagon. N-O-N-A. Nonagon. 10 is decagon. Okay, there is one for 11, but we use it so very rarely that I'm not even going to list it. Okay, 12 is dodecagon. Okay. And then any other number besides these, so 11, 14, 13, so forth, we just have the number and we put dash gon on the end, n-gon. So if I had a 20-sided figure, I would call it a 20-gon and write it like that. That's what that means, that n-gon thing here. Okay. There's 2 different types of polygons. There are convex polygons and concave polygons. I always like to say concave polygons cave in. So concave means they have some point where they cave in a bit. An example of a concave. Okay, I'm going to draw. Here I'm doing a hexagon. I drew 4 sides of this hexagon, but now for these other 2, I'm going to have them cave inside. So this still has 6 sides. 1, 2, 3, 4, 5, 6. So this is still a hexagon, but it is now a concave hexagon because it caves in. Okay, if it doesn't cave in, for example, I can do I'm going to draw another hexagon that doesn't cave in to, let's go, I should use a ruler instead, 3, 4, 5. So here's another hexagon, and this one is convex. It does not cave in. 1, 2, 3, 4, 6. As long as it has 6 straight ruler sides, it's closed, meaning if I'm inside, I can't get outside. It's a hexagon. It doesn't need to be the pretty little hexagon like this. There are other hexagons besides that one, as long as it has nice 6 sides. We'll talk about what the name of that one is here in a minute. Okay. So let's classify each polygon by the number of sides, tell whether it is convex or concave. So first let's count the sides. A lot of times it helps to mark. So here there's 1, as you're counting, 2, 3, 4. So that's got 4 sides. So since it's got 4 sides, I would call it a quadrilateral. Do you see how we can't call all 4-sided figures a square or a rectangle? Because they aren't all a square or rectangle. This is a quadrilateral, 1, 2, 3, 4. It's 4-sided. It's not a square. It's not a rectangle, but it still is 4-sided. So this is a quadrilateral, and then tell whether it is convex or concave. Well, does it cave in anywhere? Yep, we've got this cave in right here, so that makes it concave. Okay, now here the example 1b. Again, let's count the number of sides. 1, 2, 3, 4, 5, 6. 6 sides. It's got 6 sides, which makes it a hexagon. It does not cave in anywhere, so that makes it convex. Okay. All right, next side. Perimeter and area. It's important to remember what perimeter, to know what perimeter is. Perimeter, if you don't remember, is the distance around an object. It's the distance around. We measure that in linear measurement. It's a linear measurement. What I mean by that is it's measured in straight line measures, such as feet, miles, feet, centimeters, miles, inches, etc. Just straight line measurement, how far, what's the distance all the way around a figure. So if I have a triangle and I want to know the distance all the way around, all I need to do is add up all the sides around the figure, okay? And that's just in general, any figure. If I want to know the perimeter, you just add up all the sides. So you add up all the side lengths. Add up all the side lengths. Okay. There's some formulas down here for it, but I would highly encourage you, don't memorize the perimeter ones. Okay. Because I feel like it's way better if we just know what perimeter is and just add up all the sides. So here for this perimeter, I'm just going to add up this side plus that side, A plus B plus C. Okay. For a square, I'm just going to add up all four sides. Well, since all four sides are the same length, adding up this side would also be S, this side would also be S. So basically I'm taking S plus S plus S plus S, which is the same as taking 4 times S. That's where this comes from. It's not magic. Okay. And in a rectangle, if this is a length is W, then so is this one. If this length is L, then so is that one. So I would take W plus L plus W plus L. So I'm adding 2 W's and 2 L's. That's where that perimeter equation comes from. But again, don't memorize it. Just know for perimeter, you add up all the side lengths. Okay. Now for area. Area is the measure of space. It's the space inside a figure. It's how much is inside of this. Okay. For example, the difference between the two. Perimeter would be the amount of fencing needed to fence in a pen. Here, if I had this pasture and I'm talking about the perimeter, I'm talking how much fencing would I need to fence all the way around it. Now if I'm talking of the area, it's how much space is inside of that. How many acres? Acres is a measurement of area. Acres, square miles, square feet. So it's space inside a figure. It's measured in square units. Because really what we're looking for is how many squares. If I was to divide this rectangle up, it's how many of these squares are inside that figure. How many square units? If I'm measuring in feet, how many squares, foot by a foot, fit inside that figure? Okay, so that's the area. Okay. If you remember from previous classes, to find the area of a triangle is really just half of a rectangle. So here, if I was to draw in this rectangle has a base length of B, a width of H. So if we think about it as an array, this is a B by H array, but the triangle inside of here is just half of it. So to find the area, I would need to take half of the base times the height, or half of length times width. But make sure you know that this height right here is that straight up and down perpendicular height to the base. So again, we have that perpendicular height in there. Okay. To find the area of a square, again, the length is S, the width is S. So again, if we think of this as an array, a multiplication problem, okay, if this is 4 and this is 4, this is a 4 by 4 array, so to find the area inside of this, I'd multiply 4 by 4. Or if it's not 4, let's say it's something else, let's say it's S, I would multiply S by S. So the area is just S to the second. Okay. Okay. And for a rectangle, since the length and width are different, I would need to multiply the length times the width. Again, it's just that array idea. If you remember array, like that array for multiplication, like if I had 4 times 6, we could think of it as a 4 by 6 array. How much is in it? It would be 4 rows of 6 each. Okay, so there would be a 24 inside of there. So 24 square units inside of there. Okay, that's the same idea with a rectangle. Okay, so find perimeter and area, Okay, if I have a coordinate plane, that's nice because then I can use my distance formula from the last section to find the lengths of things. So if I want to find the perimeter of triangle ABC, with the vertices A is at -2, 3, so -2, 1, 2, 3, so here's A, we'll label it -2, 3. B is at 3, -3, 1, 2, 3, -1, 2, 3. There's B, sorry, 3, -3. And C is at 2, -3. Do that right? -2, 3. 3, -3. Okay, there's C. C is at 2, -3. Okay, so now if I draw my triangle, connect the dots, B to C, C to A. Okay, so if I want to find the perimeter of this crazy figure, I need to find the length of each side. Okay, first things first, look for your straight, look for horizontal and vertical, because then I can very easily just count the length if possible. Like right here, I have a straight horizontal with a length of 1. So I know the length from B to C is 1. So really what I need to do here to find the perimeter, I need to add up all three sides. So I need to add up the distance from A to B plus B to C plus C to A. Well, we know the distance from B to C there is 1. So we know this little bit is 1. We don't know the other two pieces. I don't know that. I don't know that. So we're going to have to figure those out. So to do that, I'm actually have to use the distance formula. If you remember our distance formula for the other day, let's write it down. Distance formula equals the square root of x sub 2 minus x sub 1, subtract our x's, square it, plus y sub 2 minus y sub 1, square it. So I'm going to need to do that to find A to B. So let's find A to B first. Okay. So over here I'm going to find the distance from A to B. It's the square root of. So now I need to take my x's and subtract them. So let's go -2 minus 3 squared plus 3 minus a -3 squared. So then I'd have the square root of -2 minus 3 is -5 squared. 3 minus a -3 is the same as 3 plus 3, which is 6 squared. -5 squared is 25. 6 squared is 36. The square root of 25 plus 36 gives me the square root of 61. I'm going to leave that like that for now. So A to B is, I'm going to put it over here, the square root of 61. We'll approximate here in a minute. So that's the distance from A to B. Now we need to find, and we have B to C, so now we need to find the distance from C to A. So let's find the distance from C to A. Let's see if we can squeeze it in here. I should have written a little smaller. Square it up. So now I'm going to subtract my x's from C to A. So I'm going to take 2 minus a -2 and square it, plus -3 minus 3 and square it. So I'll have the square root of 2 minus a -2, that's 2 plus 2, 4. -3 minus 3 is -6, quantity squared. So 4 squared is 16. -6 squared, -6 times 6 is 36. 16 plus 36 gives me the square root of 52. So we only want to approximate once, so I'll say P then. And since we're going to approximate, we're going to round, I'll use the approximately. This is the approximately symbol. Whenever you do any rounding and the answer isn't exact, you need to use the approximately symbol. Okay, that's attending to precision. That's one of our 8 math practice standards. Okay, so now I'm just going to type in this whole thing. The square root of 61, arrow over to get out of the square root, plus 1, plus the square root of 52. Arrow over 16.02. 16.02, and we don't have units here, but I know it's linear units, so I'll just say units is the perimeter, approximately 16.02 units. Okay, one more example and we're all done. We want to find the area of triangle DEF with these vertices. D is the point 1, 3, 1, 3. At E is the point 4, -3, 1, 2, 3, 4, down 1, 2. There's E, and F is the point, -4, -3, F. So here's my triangle. So to find the area, I need to find the area of the rectangle and take half of it. Again, 1/2 base times height, so let's write that down. So now I need to find the base. Well, it's up to you which base you use, okay? But I always like to, if there's any straight horizontal or vertical, that's the easiest one to use. This one's straight horizontal, so let's have this be my base, because I can just count what that is. It's 1, 2, 3, 4, 5, 6, 7, 8. So my base is 8 units. And then my height is that straight vertical, because again, your height needs to be perpendicular to your base. Well, if this is straight horizontal, then my height would be a straight vertical, and I want it to go through this other point. So I'm looking for a straight vertical, comes down here, because it needs to be perpendicular with that base. Again, if you don't remember, perpendicular is making a right angle, it needs to make that right angle. So then I can just count this one too. 1, 2, 3, 4, 5, 6. So my height here is 6. So I have my base, I have my height, so my area is 1/2 times the base, which is 8, times the height, which is 6. So I'm just multiplying three things. I'm going to multiply the 1/2 times the 8 first. 1/2 times 8 is 4, times 6 is 24. And area is measured in square units. So my area is 24 square units. Okay. Now what I want you to do is, once you're done with the video, I want you to go ahead and write the practice problems down here at the bottom. The practice problems are located right below this video on the web page. So jot those down, okay? If you had any questions on any part of this video, please bring it to class, ask a peer, ask your teacher, okay? If you don't have any questions, get started on your practice problems. Good luck.